Welcome, everybody. For those that don't know me, my name is Glenn Kilmer. Our company is Kilmer Environmental. We're a manufacturer's agent here in Ontario. Longtime supporter of ORAC. I'm not going to get the exact year right. I keep asking Mike and he keeps giving me the answer, but I believe it's approximately 20 years we've been supporting as the association as an associate member.
Yep.
And we're here today to speak about air exchange heat recovery wheels, both sensible and total enthalpy. Mainly we're talking about the total enthalpy wheels today, which are both transfer dry heat and wet heat. And the reason this is near and dear to me is because these are the wheels that our major manufacturer, Aon, uses. You can see a picture of actually a picture here of an air exchange heat wheel that easily slides out of the side of an Aon unit. And then I won't go too much into depth on the wheel itself yet. Then that's going to give that to Chris to talk about in a second. But wanted to say thank you to ORAC for hosting us today. It's great to be able to have the opportunity to be seen, I guess. I miss all the in-person interactions that we have at our events and at the golf tournaments and whatnot. So hopefully we can get back to normal soon. So thank you to ORAC. Just a little bit on Kilmer. Dad, Tom Kilmer, started it in 1987. For those of you that don't know, we've been around for quite some time now. Ed Carney and I are the current owners of the company, and we're located in Mississauga. A lot of your techs probably know where our parts counter is. We have a fully stocked parts counter with all the Aon, Condair, Nortec, and Ceresco parts. And with that, I don't want to take up too much time, so I'm going to pass on the baton to Chris Glover. Chris is with Air Exchange in the States, and I'll pass it along. Thanks, Chris.
Great. Yeah, thanks for that introduction. Great to be here today. Just going to begin by kind of going into a little bit of background on Air Exchange itself. So the company itself is founded in Rockland, Massachusetts. So for those of you who don't know where Rockland is, it's just south of Boston. We currently have over 300,000 wheels in the market, and that number is growing. We are a charter member of the HRI EERV committee. We are a member of the 90.1 mechanical subcommittee. We're a member of the 62.1 ventilation committee, and we're also a member of the TC55 energy recovery committee. We're currently the largest supplier to HVAC OEMs in gross volume for energy recovery components, and all of our products are HRI 1060 certified. So I'd like to start the conversation off today by saying that I'm going to discuss synthetic segmented energy recovery devices. That's my area of expertise, and in particular, this technology works very, very well for existing building applications. So if you're servicing existing buildings, I believe this technology lends itself well to that. So in terms of the agenda today, we are briefly going to go over the overview and benefit of the ERV technology. For some of you, this may be a refresher. For some of this may be new. We're going to look at what some options are for refreshing performance in existing buildings and servicing those units. And then we'll go over some project profiles where contractors have successfully used this technology to service existing equipment. Okay, so I'm going to take a few minutes to kind of set the stage a little bit. And, why should we be interested in replacement energy recovery components? Well, really, since the 1970s, the application of energy recovery technology has grown quite considerably, not only in just sheer installed quantity, but also in building diversity. You're just seeing them in a lot of applications that they were never traditionally in. However, when these devices are come into in need of repair, I find that they're often overlooked for mechanical repairs and service. And I really believe that comes down to a lack of understanding, cost, and complexity of the devices. So, aside from energy recovery, aside from the primary heating and cooling element, the energy recovery device provides the building's next largest source of air conditioning. So it really does play a vital role in the system's ability to condition the space air. And so recognizing that is going to, go into, it's going to recognize the importance of this device goes a long way in developing a proper maintenance and service strategy. So with the pandemic going on, there's been a lot of talk about ventilation and the benefits of dilution. Both ASHRAE and the CDC are recommending that you that you minimize, or excuse me, that you maximize ventilation in existing buildings. And a lot of you could probably understand what the challenges of that may be. So outside temperature is very difficult to predict. So if you look at the psychrometric chart to the left, you can see that you have large swings in outside air temperature and humidity. What that dotted line represents is what essentially is at any given point on any given day, your operational point could be within that dotted line. The blue dot and the red dot represent your typical indoor conditions. And, as the outside air starts to move away from those points, the more energy you're going to consume to try to condition that air. So, as the points get more extreme, obviously, the more energy you use and you encounter difficulty trying to maintain occupant comfort. So, an energy recovery component is generally just a fancy name for an air-to-air heat exchanger. The easiest way I can describe the process is that all year long, all this device wants to do is bring the outside air as close as it possibly can to the indoor building condition. And depending upon how effective that device is going to determine how close it gets to those points. It's a passive process, so it only requires a difference in temperature and humidity to perform this work. There's no mixing of air taking place, except for the small amount of seal leakage due to differential pressure. So it's all thermal energy or latent energy that's being transferred. And what it really does for you is it dramatically shrinks the operational window associated with ventilation air. So once again, looking at that psych chart, that dotted line represents the outside conditions without energy recovery, and that solid line represents the new operational window based upon including an energy recovery device. And really the difference between those two is the operational savings that these devices will get you. Also, that reduced operational window also creates a more ideal condition, for your primary heating and cooling system. So it allows you better control over the air being delivered to the space and makes the discharge conditions far more predictable for better results for occupant comfort. So just quickly to summarize, an energy recovery device, allows you to maintain, either maintain the minimum rates or increase your ventilation rate cost effectively. And in the pandemic environment, that's a very useful tool to have. We're all looking ways to maximize ventilation. It helps you buffer the outside air conditions. So as it starts to get very hot or very cold or very humid, it helps buffer those to a more manageable point. It's one of the few devices in the market that allows you to reduce peak energy demand, meaning the hotter it gets, the colder it gets, the more work these devices actually do for you. If you're using it in conjunction with a DX system, most DX systems, the efficiency has a tendency to drop off as you start to moisture load the coil. These devices will actually remove moisture prior to it getting the coil, so it allows your DX system to operate more efficiently. It allows for better humidity control. Now, humidity control, often is referred to solely as a function of the summer operation, but there really is an added benefit for winter operation, especially in predominantly cold environments where you have that very dry, cold air coming into the building for a majority of the year. It allows you to retain some of the indoor humidity, so that humidity just doesn't escape the building. And with what ASHRAE and the CDC has come out, it's shown that combinations of temperature and humidity control really are vital for boosting the body's natural barrier against against contaminants. And lastly, it allows for, this is more for new construction, but it allows for downsizing the primary and heating and cooling components. So as you shift the ventilation load from the primary heating element or cooling element over to the wheel, it means that you can downsize the subsequent system accordingly, because that now the wheel or the plate is handling that load. Okay, I want to talk a little bit about codes. I'd like to preface this statement, but I'm not an expert on the Ontario Mechanical Code. So, Glenn was nice enough to forward me this information over. The Ontario Ventilation Code uses standard 62.1. Now, standard 62.1 is the ventilation standard for acceptable indoor air quality in buildings. And there's a couple of quick things I just want to point out about this. Standard 62 is not a health standard, meaning that disease transmission was never considered during its development. There have been changes over the years where health-related impacts are now being considered where appropriate. However, the rates are largely based on what it takes to dilute what most people consider normal space air, which is, mostly bioeffluent, contaminants from people, or sources within the space, or, off-gassing from sources within the space, furnishings, or any processes that might be taking place in there. And the ventilation rate provides what the minimum rates are to achieve proper dilution. And you might see that I highlighted minimum ventilation rates because, as with most code-related mandates, the minimum often becomes the maximum. And as we're seeing, with the pandemic, these minimum rates usually don't provide the best benefit during these periods of crisis. Okay, so the Ontario Energy Code actually has 3 different paths for compliance, and they're all for new construction. So, unfortunately, it doesn't look like there's any code-related mandate for existing buildings other than to replace with, quote unquote, like or better. Now, I highlighted better because ERBs can really assist in the better department. The first compliance path is ASHRAE Standard 90.1, which is the energy standard for commercial buildings. The second path is the National Energy Code for Canada. Both use a very similar methodology, or exact methodology for determining energy recovery. And the third is the Standard 189, which is what I consider the stretch standard, or the high performance standard for commercial buildings. Okay, so before we discuss the opportunities as it relates to service and existing buildings, I wanted to state that energy recovery is an engineered component. And you might be asking yourself, why does that matter? Well, it really matters because there is no standard of design with these components. As you go from manufacturer to manufacturer, the manufacturing process is going to vary. The tolerances are going to vary. Dimensions, materials, performance is going to vary. So you're left with essentially an infinite amount of configurations. And while that might sound kind of difficult to navigate, we have, as an industry, spent a lot of time developing processes and resources necessary for folks servicing this equipment to be as successful in this environment, all in kind of an effort to minimize complexity and make it easier for you. So there are 3 kind of different options depending upon your situation. The first is what I call the site-built kit, and it's really used to replace older inoperable components on site. So the kit allows you to replace very large heat exchangers, and some of these heat exchangers can get quite big, using pre-assembled site-built subassemblies. So the benefit of these kits is it usually eliminates the need for any major building or HVAC unit modification. The second is what I call the sliding cassette replacement. Sliding cassettes are traditionally smaller in nature, as long as there's no acceptable amount of space to maneuver the new component within the allotted space in the unit. The benefit of this is there is no on-site assembly required of the new component, so it helps minimize labor. The third is a media segment cleaning and replacement. So depending upon the age and condition, segmented synthetic energy recovery wheels allow you to take the energy transfer segments out so you can wash them and clean them over time, or replace them, depending upon the relative condition of the device. So let's take a quick look at these in a little bit more detail. Okay, so starting with the kit is what I consider the most popular way to replace an existing wheel. It's used in a lot of applications where manners of egress and space that surrounds mechanical equipment is limited, which is, let's be honest, a lot of buildings. All the pieces are designed to fit through a standard door and are compact and light enough for to be handled by 2 assemblers. So they're designed to be able to be maneuvered within the space and within the confines of the equipment. In most cases, it completely eliminates the need for a crane or any type of building or unit modification. And this can be quite a big deal because if you're trying to replace a monolithic wheel, these large monolithic wheels can sometimes put you in a position where you're looking at removing sections of a roof or an entire section of an air handler. Also, you have to take into consideration any rigging or preparation, which could also be added to the labor. This kind of eliminates all that cost and complexity. Typical diameters range from 58 inches to 165 inches. which equates to 4,000 to 65,000 CFM. So they get to be quite big. The structure of these units all use standard fabricated parts, which cuts down on the cost and lead time. But even though you're using standard fabricated parts, the performance of these devices can be tailored to any application. And in most cases, I've come across, you can even provide better performance in terms of thermal and latent transfer and pressure drop than what was existing. These components are assembled in the factory, and then they're broken down for shipment to the site. I'm going to show you a quick video here. Hopefully it runs on your end of kind of a 30-second time lapse of a 35,000 CFM wheel being built in a building. Once again, the kit itself, it gets assembled with common hand tools. So we're really, nothing fancy about it other than just rivets and bolts and screws. And this is really how quickly it gets put together. So really nothing fancy to it. Okay, for slide-in replacements, certain OEMs, I know Glenn mentioned Aon's one of them, but there are others out there, develop cassettes into a track system where you can actually slide them in and out of the HVAC cabinet. So in certain cases, when you need a replacement or to service it, you can simply slide the old one out and slide a new one in, depending upon the manufacturer. Also, depending upon manufacturing, you may need some additional, blank off panels, depending upon any dimensional differences between the sliding cassette, between the new one and the old one. I will say, blank off panels aren't fancy. They're just bent sheet metal, and they're just there to keep the air from bypassing around the cassette. So these are available typically between 25 inches in diameter to 74 inches in diameter, but that's not a limiting factor there on the upper end. They can go larger than that. As long as you're not concerned with the overall size and weight of the device. And the typical airflow range is between 500 CFM to about 13,000 CFM is where you see most of these being used. And once again, because there's no assembly of the device on site, these can be quite cost effective for certain applications. And as I mentioned before, for synthetic segmented wheels, segment cleaning and replacement is an option. So unlike the older, traditional monolithic style wheels, if there is no mechanical damage to the segment and it's just a matter of it being dirty, you can always take them out and follow the manufacturer's standard cleaning procedure, which is usually just letting the media soak in a soapy solution. I like to say any common degreaser works really well here. So Dawn, fantastic. Anything that kind of loosens up any type of oily residue that may accumulate over time. And then you just rinse it off with normal tap water, and that process brings that cassette back to, or that segment back to the original performance. So there are times where you may need to replace them. So that's could be if it was subject to mechanical damage. Maybe someone went up to the service of the unit and accidentally put a hammer through something. Or if it's just at an age where it's time to replace them with a new set due to some deterioration of the material over time. A typical segment swap out usually takes about 20 to 30 minutes for damaged segments. And once again, because it's segmented in nature, if you are replacing a damaged segment, you don't necessarily have to replace the entire wheel. You can look at just replacing that singular piece to help save your customer cost with the device itself. The segments themselves range from 25 inches all the way up to 156 inches. And they're all designed to be light enough and compact enough so that one person is able to do the segment removal and reinstallation process, and cleaning process, I should say. Okay, so how do you assess, what needs to be done to the device? Now, some of this may seem kind of trivial, but I just like to point it out. The first step is to identify, you should be asking, so what's the relative age of the equipment? A properly maintained energy recovery component, the lifespan should be about 15 to 20 years. So, if this device has never been maintained over that course of operation, it could be substantially less than that, depending upon what it's been exposed to. Is the device functioning? And I like to point out that just because the device is spinning doesn't necessarily mean it's functioning. So you have to make sure that you're achieving your desired ventilation airflow, that you're maintaining, the pressure drop that's set by the manufacturer, as well as the overall effectiveness that the device should be working at. Is the device mechanically sound? Are there any mechanical deficiencies like heat transfer medium missing, or significant rust or corrosion? Any visual bridging or gapping or media plugging that would minimize the airflow being delivered to the space. And lastly, if it's just dirty, can you physically clean it? Some devices are a little bit easier to clean than others, so that's something that you should be asking yourself. The older the device gets, and the more you say, the more no's you start to answer these questions, the more likely you're going to be in a replacement versus a repair scenario. Okay, so how do you identify a candidate for replacement? So here are some kind of visual cues of wheels in various states of repair. Each of these pictures kind of demonstrate severe corrosion or plugging or mechanical failure. So it's usually pretty apparent when the device has started to exceed its operational lifetime. And as I mentioned before, the typical lifespan that I see for these devices in the market are usually 15 to 20 years. They can exceed that through proper maintenance on the devices. I've seen them go well above that. It's just a matter of what type of condition and what these wheels have been exposed to, and how often they follow the manufacturer's recommended procedure. Okay, so let's say you identified a potential for repair, or replacement. So what's your next step? So since this device is part of an existing system, the most important aspect of replacement is to either match or exceed the original design. That way the system can operate as it was initially intended. So this is going to include sensible performance, latent performance, pressure drop, and leakage. All of which are HRI certified, I should say. So, you may be asking yourself at that point, am I intuitively supposed to know all that? And I can answer that, no, you're not. That's kind of why Glenn and I are here, to provide that level of support. So, your first step should be, requesting and filling out what I call a replacement component form. So it's a one-page form, and you basically fill it in with information that should be available just by viewing the components. So just going up and opening up the cabinet, you should be able to ascertain 90% of what's on this form. And really, this gets us about 95% of the way there when, kind of developing a replacement strategy or a repair strategy, depending upon, what you have inside the unit. Okay, so and in terms of deliverables, after you send a replacement component form in, what can you receive back? You can expect shop drawings, electrical information, skid dimensions, and weights, as well as product assembly and maintenance documentation. This is all going to be pretty vital for you in terms of developing the strategy for replacing or repairing that particular component.
Chris?
Yep.
A couple questions before we get to the rest of the presentation, which I think we're getting through.
Okay.
Do you have any recommendations on what type of filters to use upstream of the wheels?
Well, previously, most people go with, it's really up to the OEM, but filtration, the wheel doesn't act as a filter per se. So, if the particle is big enough to fit through a filter, most likely or if it's small enough to fit through a filter, small enough to get blown through ours. And then, discharge down the wheel, it was typically MERV 8s, but now in pandemic periods, ASHRAE and the CDC are recommending MERV 13 or higher. So certain OEMs just have your standard mist eliminators, bird screens before the wheel. If you can put MERV 8s before the wheel, I will say that it will lengthen the time between maintenance periods. So that's really what that is going to accomplish for you. Is if there are certain amounts of industrial pollution where this unit is, let's say it's next to a highway, or our manufacturing plant or something like that, where particulates are pretty heavily present, having some MERV 8s there will definitely assist you in that manner.
Thank you. Hopefully that answers the questions there. I did like that we got to fit in that ASHRAE guidance on the pandemic. ASHRAE.org has a fantastic pandemic website if anybody wants to go there and get some impartial information. It's clickable. There's a map. It's really cool. The second question that popped up was just time between cleaning the wheels. I know that's going to definitely, you just answered the question. It's definitely going to depend on how dirty the air is inside the building and how dirty the air is outside the building. I mean, if you have an air handler near a helicopter pad, which I heard a story of once downtown Toronto, you know, you can get a lot of diesel exhaust or a smoking environment. So maybe you could just touch on that quickly.
Yeah, sure. So if you go to our website, and I'm by no means, you know, saying that you have to, but what we've done is we've kind of combined our cleaning cycles with what ASHRAE has developed in terms of classifying exhaust air that's used for energy recovery devices. So if you read through the ventilation standard, there's 4 classes of air, and they vary upon, you know, the concentrations of contaminants in the air. So class 1 being just, you know, kind of general clean air, class 2 being mild contaminants, class 3 being heavier contaminants, and class 4 being lab exhaust and paint boost and stuff with, you know, significant nasty stuff in it. The majority of building spaces are going to be class 1 and class 2 air. Okay, so that's 90% of what you're going to be serving in. And what we typically recommend for class 1 air is you're typically looking at maybe 5 to 10 years between cleaning segments. So this is not something that you have to do all the time, but what we typically recommend in lieu of doing cleaning assignments is have an annual inspection, a visual inspection of the device every year. So if you're going to be servicing the unit, once a year, go up there and just do a couple of visual checks on the device just to make sure that it's operating properly. As you go to class 2 air, you're probably looking at between, you know, 3 to 5 years between cleaning segments. Class 3 air, which is the biggest one that I can say class 3 air is right now, is casinos and cigarette smoke. You know, typically those ones you're looking at 1 to 2 years. In class 4 air, you most likely aren't using energy recovery devices in those airstreams due to the, you know, concentrations of contaminants or the stuff that's in the air. So that's kind of based upon the relative quality of the air that you're exhausting through the unit.
Thanks, Chris. I just wanted to add, there are ways to segment your return and your exhaust airstream so that you can, for instance, if you have general exhaust in a building and you also want to increase the energy efficiency in the building, and you also wanted to bring back some washroom exhaust, which is class 2 air, we can actually, you can actually segment the, like an air handling unit so that you have 2 connections, one for return and one for toilet exhaust, and internally sort of divide them so that the toilet exhaust is only allowed to go out through the wheel, out the exhaust fan and leave. And the other airstream, part of it can get exhausted through the wheel and part of it can get recirculated, and they don't mix very much. So there's lots of interesting things you can do with wheels.
Yeah, very good point.
I'll let you continue. Thanks, Chris.
Okay, great. Just kind of diving back into it. So just quick rules of thumb when you're looking at a replacement project. So, you know, for the majority of projects that I've been involved with, you know, we typically recommend having 2 to 3 people available for removal and assembly, and maybe 1 to 2 people for repair. In most cases, we find that adding more people usually doesn't cut down on, you know, on the labor, and that's because, you know, you're typically working within the, you know, the tight space constraints of the existing HVAC cabinet, and, you know, the tight constraints of a penthouse or you know, a mechanical room. So there's only really so many people that you can throw into those spaces. The only time I can really recommend bringing more people to the job is if you have multiple air handlers or multiple units that have multiple repairs that you're doing. So that way you can kind of divide and conquer, and that will sometimes eliminate it. But if it's just one unit, usually having more than that really doesn't add a whole lot to the cutting down on the time and labor. It typically takes 1 to 2 days to remove and dispose. Now, usually the heavy lifting is really in this part. I will say that it's not that fancy. My best experience have been with just someone going out there with an angle grinder and sawzalls with a couple of really nice Diablo blades, and they actually kind of get removed pretty quickly. It's a lot, you know, it looks a lot harder than what it is. So in terms of assembling or repairing, it's usually, you know, 1 to 2 day assembly depending upon size. The bigger you get, usually it's a little bit more towards the latter end. And then it's usually you're left with 1 to 2 days of what I call your supplementary stuff, where you're wiring up and you're performing the startup process of the new component and the commissioning of the new component. So it's not a terribly long project to do this, and it's something that's going to provide years and years worth of benefit to the customer. Okay, I have 3 project profiles. Hopefully I didn't bore you with all that information, but starting off with the Wentworth Institute of Technology. Now, we have kind of a similar weather pattern down here in Boston, so you'd probably expect something like this up where you are, although you have a little bit longer cooling season or heating season than what we do. So this project, it was located in a really congested urban location. Boston is pretty big these days. There was a very limited access to the unit. So the components had to go up an elevator, had to go into a mechanical room. It had to get offloaded in the city of Boston really quickly. They could not use a crane. It was, a pretty, it's pretty tight space. Compounded on that, this was an over-under air handler. Now these add a little additional level of complexity, because you got those half doors on the air handler where all the components have to fit through. And this is a 6-foot air handler, and those doors are only 3 feet tall. So you can see what the complexity is there. This device was an 8,000 CFM wheel, and we provided the kit form for this building. So all the pieces were able to be taken off the truck, brought up through the elevator, got into the access, and we were able to get it into the cabinet without any structural or unit modification. So that's kind of what the feature was for this design. And everything got built up inside the air handler. So just kind of really to summarize that project, it took about 2 days to complete. And that was 2 units that received that. So it saved about 3,700 therms annually. The equipment cost was about $9,000. The operational cost savings is about $5,000 annually. Because this was saving so much gas local to Boston, they applied for a energy rebate due to the peak demand, and they were able to receive a $5,000 rebate from the utility. And the simple payback on just the equipment itself is less than a year. So overall, it was a pretty successful project with a minimal amount of time and labor put into it. And now that particular building can receive the benefit for many years. So this is a correctional facility that we did down in Virginia. So it's an example of what I call a sliding cassette. So this was a cassette that arrived fully assembled. Essentially they slid the old one out and slid the new one in. And the biggest concern for the owner on this one was downtime. And the original wheel failed. It was a monolithic wheel, so the original wheel failed due to delamination. So you can kind of see some of the media sections starting to separate there. The units were on ground level on pads, so getting access to them were really easy. And due to the relative size and weight, we were able to provide those slide-ins where they could just physically pick them up and slide them in. Both units, there was 2 units on this project, were installed in a day. Both were completely installed in a day. No assembly was required. It did require a subtle amount of sheet metal flashing just to kind of block off some of the dimensional differences. The operational savings is about $14,000 annually. Now, this is an area in the country where they have about equal heating and cooling savings. So, some of that's in the summer, some of that's in the winter. The cost of the equipment was $12,000, and the simple payback on the equipment it was less than a year for this project. So slide-in cassettes are kind of a fantastic way if you have the ability to maneuver in the space. Really good, cost-effective option. This is the AT&T headquarters in Miami, Florida. The original media failed due to severe plugging over time. The wheels got very dirty, and the owner couldn't clean them, which caused the wheels to fail. It was a really big energy recovery wheel. So it's 170 inches in diameter, roughly 60,000 CFM of outside air in Miami. So you can imagine how much air conditioning load that placed on the building. So this project was unique in a couple of ways. Once again, it had very limited access, and it was in downtown Miami. So this is limited access to the building, limited access on the street. Once again, it had to be done while people weren't present inside the building. So we had to complete it over a weekend's time. So the contractor essentially came in, removed the old wheel. We provided a kit based upon the existing site-related wheel. And the entire project was able to be completed during 1 weekend's worth of time. So they started it on Saturday and they finished it on Sunday. And the benefit here is now when the unit gets to be dirty like it was in the original wheel, now the maintenance folks, the service folks can go in and take the segments out, wash them, clean them over time to help keep this device operating for a very, very long time. So once again, operational over a weekend. So even something that size, we were, it's able to be completed relatively quickly. Because this was in Miami, the new wheel reduced the AC load by 130 tons. So that's really nothing to sneeze at. That's a tremendous amount of load reduction. It provided about $45,000 in annual savings, and in Miami it's mostly electrical savings because it's air conditioning operation. Or excuse me, it cost $45,000. Annual operating savings about $28,000, and the payback on this particular project was about 1.5, 1.6 years. So overall, very successful projects. Weren't difficult to do and provided the customer with a device that's going to give them years and years worth of savings. So with that being said, thank you very much for attending. I really appreciate you chiming in. Here's our contact information for those interested. I'm just going to kind of leave it up on the screen. And if you have any questions, comments, I know I can kind of answer them at this time. So I'll just leave this up here for anyone who might need it. Thank you very much.
Thanks, Chris. We're here for a few minutes to answer any questions. As Chris said, I didn't get any more questions on the chat board, I don't think. We've finished a bit early, which hopefully works for everybody's schedule. I know we're all busy and it's tough doing these webinars. We're getting a lot of screen time these days, as we said before. So feel free to chime in, or if you want to send an email to Chris or I personally, happy to help you out offline.